Alright, we're going to get started on homework number 16, and it is called Polynomials and Pascal. And you'll learn about who Pascal is later on throughout this lesson, but that's the title of it, homework number 16. Okay, and the first thing you're going to see is a picture of Blaise Pascal. He was a famous French mathematician, and we'll talk about him later on in this lesson. But starting off, we're starting with polynomials, linear factors, and zeros. And question number 1 says, and I'll go ahead and write number 1, it has x to the third plus 7x squared plus 10x. And what it asks me to do is to write each polynomial in factored form. Okay, so it uses this phrase. It says factored form. That's the first thing that it wants me to do. And the second thing it wants me to do is it says find the zeros of each function. Right, so it says find the zeros. So those are two different things that we're going to need from this problem. Now, we have gone through and this year already talked about greatest common factor and being able to factor different terms. And what we're looking for right here in this first step in finding the factored form, we want to be able to pull out a common factor between our three terms. We know that this is a cubic trinomial because we have the biggest number in front there in standard form. It's x to the third power. So this is a cubic trinomial. It doesn't ask us for this. I'm just writing this out. So we have a cubic trinomial. But there's three terms, right? Trinomial, tri means three. Nomial, so we have three terms. Okay, we have x to the third. We have 7x squared. And then we have 10x. Okay, so what I'm looking at there, I'm saying, can I factor out one of the terms or one of the factors for each term? And what I can do in this example right here, I can actually pull out an x from each of these terms. So I can pull out an x from x to the third. I can pull out an x from 7x squared, and then I can pull out one from 10x. They each have an x, right? Now this one has 3 x's, this one has 2 x's, and this one only has 1. But let's say I just pull out 1 from each of them. And I can do that. I can factor it out and write it in factored form. So that's where I'm going to show you what we're doing. So if I were to say x times the quantity of, and then to write the three terms out, what if I were to change x to the third, this term, what if I change it to x squared and just took an x out, right? And then also in this term right here, 7x squared, what if I just took an x out? And then the last one, 10x, this last term, the third term, take out a 10. Because if I were to re-multiply this using distributive property, right, x times x squared gives me x to the third. X times 7x gives me 7x squared. And then x times 10 gives me 10x. So really, and I'm just going to rewrite this below, the same exact thing. Really, if I were to multiply 10 times the quantity of and use distributive property, I really haven't changed this at all. I've just taken out an x. And this is important because we want to be able to create a quadratic. And now that we've done that, we've created this quadratic, we're able to move on to the next step. Okay, so this is where I would say would be, well, I guess we're not all the way done factored form, right? I could actually factor this even further. And if you remember, we used the box method before when we were dealing with quadratics. and we were factoring different quadratics, especially trinomials. And we would take x squared plus 7x plus 10 and say, all right, how can I write this as a factored form? And we could actually factor it further. And remember, we used to do something like this. I'll say x times, and we had a plus plus, so that means our answer is going to be a plus plus. This is a bit of a review, but this is where it starts making sense and start piecing all this puzzle together, right? So just as a review, we want to find the factors of 10 here. And the factors of 10 are 1, 2, 5, and 10. All right? So I found those factors of 10 and which two add up to 7, the middle term. And we've determined that 5 and 2 both add up to 7 and multiply together give you 10. So if I were to multiply this out, right, x times x is x squared, x times 5 is 5x, x times 2 is 2x, 2 times 5 is 10. Okay, so I add all that together and I would be able to get my original x squared plus 7x. I'll go ahead and write everything out. I can combine these two terms and get x squared plus 7x plus 10. Is this the same exact thing as what we started with right there? And the answer is yes. Okay, so now I'm going to go back to where I was at. We had x times the quantity of x plus 5 times x plus 2. All right, now we've taken what we started with. If you remember, I'll rewrite it up here. X to the third plus 7x squared plus 10x. This was the original problem that we started with, right? We took that and have so far transferred it into factored form like this, okay? Now we have completed the first step where it says put in factored form. The second step, it says find the zeros. And the way that we would find the zeros is just by setting this equal to 0. And we would take each term, x, and set each term equal to 0. So I'd say like x is equal to 0, x plus 5 is equal to 0. See how I just like brought that down? And then I do the same thing over here, right? I can say x plus 2 is equal to 0, right? X plus 2 is equal to 0. So when I'm finding the zeros, when I'm being asked or told find the zeros, I would really just set everything equal to 0 and then set each term equal to 0. So I'd set x equal to 0, x plus 5 equal to 0, and x plus 2 equal to 0. And we would find each, right? So once again, so x equal to 0, x plus 5, in order to solve there, I'd subtract 5 from each side, and I get x equals negative 5. Subtract 2 from each side, and I get x equals negative 2. Okay, so my zeros are x equals 0, x equals negative 5, and x equals negative 2. So I can just write something like this. I could say x equals, I'll just write them in order. I'll say negative 5, whoops, negative 5, negative 2, and 0. Right? Or if I wanted to, I could say x equals negative 5, x equals negative 2, and x equal to 0. I'd accept either one, right? You can write it like this, or you can write it like what you did below. It's entirely up to you, all right? I'll accept either. Sometimes it might just be best at the very end of the problem, like just to like circle what each x equals. Like that would be okay as well, but I'll accept it. So really, we've written it in factored form, right? This is what we eventually got down to in factored form. And then once we found it in factored form, we then found the zeros, right? So we're going to practice this a few more times, 3 more times to be exact, right? So we'll add another layer here, and we'll do number 2, all right? So if you're confused on number 1, that's okay. We're going to practice it. We're going to get this. So we'll start off x to the third minus 7x squared minus 18x. And remember, the two things I want to do is I want to find it into factored form, and I want to find the zeros. All right, so the first one, x to the third minus 7x squared minus 18x. These are my three terms, right? I have three terms. And I want to be able to find a common factor. If I can take one of the x's out, that would be great. And it looks like the case here that I can take an x out. And I can just say x squared minus 7x minus 18. And once again, the reason why I'm able to do that is by the distributive property, I could say x times x squared gives me x to the third, right? I could say x times negative 7x gives me 7x squared. And I could say x times negative 18 gives me 18x. So I'm able to put this into factored form. But now if I want to move a step further, right, I have a minus minus. When I want to factor a minus minus, I would get a minus plus. Okay. In the beginning of the year, we talked about this in factoring. Remember that if we have a plus plus, that will give me a plus plus. A plus minus will also give me a plus minus. A minus minus will give me a minus plus, and a minus plus will give me a minus minus. So in this case, we have a minus plus. The last one I just wrote out right here, we have a minus plus, so our answer, we have a minus minus, so our answer is going to be a minus plus. All right. So let's use the box method. Let's write this out. All right. I know that I have to route the factors of 18. So I have 1 and 18. I have 2 and 9. I have 3 and 6. 3 times 6, 2 times 9, 1 times 18. And those are my factors. So which two, if I know that one of them has to be a minus and one of them has to be a plus, right? Which two, and you can sometimes move trial and error. I like to start with the middle two and move out. But I can see, right? Well, I guess, let me just show you. I guess I'll start with the middle two. It's not going to work, but let me show you, right? The middle two are 3 and 6. So if I were to try 6 and 3, x squared, negative 6, 3x, negative 18. If I add up everything that's in the box, I get x squared minus 3x minus 18. Okay, that is not the same thing as above and what I started with, so I know that's wrong. And I could see that from the beginning, so I'm just going to head and cross it out. So the next two terms, you could switch the 3 and the 6, but that's not going to work either. I can already see that. So if I were to go ahead and try the next two terms, 3 and the 6 didn't work, right? So I'll go ahead and cross them out. Let's try the 2 and the 9, okay? And I know the 9 is going to be the negative because negative 7 is the bigger number here. So I'll say negative 9, and I'll say plus 2. And where to get these numbers from? This is the 2 right here, and this is the 9. I know it has to be a minus plus in my answer, so let's try this out. X squared, got 2x, negative 9x, negative 18. I add up everything that's inside the box, 2x minus 9x minus 18. I get x squared minus 7x minus 18. Is that the same exact thing as what we started with up at the top? The answer is yes. Okay, so now that I have that, I'm going to go ahead and write in my x minus 9, which is what I got right here, and then my x plus 2 is what I figured out right there. I'll go ahead and rewrite it here at the bottom. And we've went ahead and wrote this in factored form. I'll go ahead and check this off the top of the screen, right? So now I want to find the zeros. The way I find the zeros is by setting it all equal to 0. I can say x is equal to 0, x minus 9 is equal to 0, and x plus 2 is equal to 0. If I stopped here, I wouldn't have the answer. I need to make sure to solve. right? So if I add 9 to x is equal to 9, subtract 2, and I get x is equal to negative 2, I could just circle x equals 0, x equals 9, and x equals negative 2. Or what I could do is I could just write it out. I could say x is equal to negative 2, 0, and 9. Either way, I'd accept either way of completing that. All right, and that's number 2. All right, we're going to move on to number 3. Number 3 is 9x to the third plus 6x squared minus 3x. Okay, and if I were to write each of these terms out, if I say 9x to the third, 6x squared, and 3x, if I were to write the factors of each, right, 9 is 3 times 3 times x times x times x for the x to the third. Okay, so 9x to the third can be written out like that. Okay, down to the prime numbers. 6x squared is the same as 2 times 3 times x, and 3 is just 3 times x. Now check this out. We can factor out more than just an x. Before, we just took an x out because that's all we could do. But now if we take a look at this, right, we can also factor out a 3. You got your x's, but then you also have a 3 that you can factor out. So if I were to factor out a 3x, that would leave me with 3 times x, which is 3x squared. And 3x times 3x squared gives me a 9x to the third, what we started with here at the top. All right, so 2x, and then I would also have a minus 1 at the end, because 3x times 3x squared gives me 9x to the third up here at the top. 3x times 2x gives me 6x squared, and 3x times negative 1 gives me a negative 3x. All right, now what I can do is I can factor out, don't forget the 3x, but a plus minus gives me a plus minus. All right, and if I were to use the box method to take a look at this, right, if I were to take 3x times x, and one has to be positive, one has to be negative, we'll add that one positive and we'll say this one's negative. We'll try this out. Sometimes it might not work on the first try, but it looks like this is going to, right? Negative 1 times x is just negative x. 3x times 1 is 3x, and 1 times negative 1 is negative 1. Right, now if I were to multiply all this, or take all the things that were in the middle, all the terms are in the middle, 3x squared minus x plus 3x minus 1, that would be able to give me 3x squared plus 2x minus 1. And is that the same exact thing as what we started with up there? The answer is yes. So I know my factored form would be x plus 1, as I have right here, and 3x minus 1, as I have right here. All right, so if I were to create my checklist of saying, all right, put this in the factored form, and then also find the zeros, we already put in factored form. Now let's find the zeros. All right, so I have 3x times x plus 1 times 3x plus 1. All right, I'll say is equal to 0. So now that I've set it equal to 0, I would set each one 3x equals 0, x plus 1 equals 0, and 3x plus 1 equals 0. Okay, divide each side by 3. 0 divided by 3 is still 0. X minus 1, x plus 1 is equal to 0. You subtract 1 from each side, and you get x equal to negative 1. If I were to set this on this side, I'd subtract 1 from each side, and I get 3x is equal to negative 1. Divide each side by 3, and I get x is equal to negative 1/3. Okay, so my three answers, x equals 0, x equals negative 1, and x equals negative 1/3. You can't just have one of the answers. Like you can't just say, all right, x is equal to 0, I'm done. That's not going to work, okay? So make sure when you go through to find the zeros that you're doing each and every one, 3x, x plus 1, 3x plus 1, and doing each of those, right? So we've found all the zeros for that problem, and that was number 3. All right, let's do number 4. All right, so now that we're starting to get the hang of this, let's go through number 4. We have x to the 3rd plus 8x squared plus 16x. All right, so I know I can take an x out. If I were to write each of these in factored form, right, so I have 8x squared, each of the terms, 16x. X to the 3rd is the same as x times x times x. 8x squared, let's see, I remember that's the same as saying 2 times 2 times 2 times x times x. In this 16, it's 2 times 2 times 2 times 2 times x. Now, even though we have 2's shared there, it's not shared among the first term. There's no 2's up there, so you can't actually circle a 2. You can still only circle an x that exists. Okay, so we can factor out an x, and we'll say x squared plus 8x plus 16. All right, from here, I'm going to use the box method. I know I have a plus plus, so my answer is also going to be, my answer is going to be a plus, plus. All right, list out the factors of 16. I have 1 and 16. I have 2 and 8. I have 4 and 4, right? So 4 and 4, 2 and 8, 1 and 16. I like to start with the middle 2 first, so let's go ahead and try those. 4 and 4. I'll say x plus 4, and then x plus 4, multiply it out. X times x is x squared. I get 4x here, 16. Looks like all this is going to work if I write it out. All right, so I get x squared plus 8x plus 16. Is that the same with what I started with up there? The answer is yes. So I'm going to go ahead and write x plus 4 and x plus 4. All right, so now check this out. I'm going to rewrite that down here, x times x plus 4 times x plus 4. Now look how x plus 4 is repeated, right? If I'm trying to find the zeros here, we already put in factored form. If I'm trying to find the zeros, it looks like it's going to be exactly the same, right? If I say x equal to 0, x plus 4 is equal to 0, and x plus 4 is equal to 0, we're doing the same thing twice there, right? So if we get x is equal to negative 4, and then also x is equal to negative 4 over here, I'll go ahead and rewrite this a little neater. X equals negative 4 over here. You don't have to, like if you're using this method of writing out x equals 0, x equals negative 4, 0, right, comma, and just like adding it all up there, you don't have to rewrite negative 4 twice. I'd accept it like that, but it's probably best just to circle what you got, right? I'll accept it. Just realizing that 0 and negative 4 are your zeros. Even though these two are repeated, I'm okay with that. All right, and that's number 4. Number 5. All right, so number 5 says find the zeros of each function, then graph the function. All right, so we're finding the zeros. Number 5 says, well, I guess I'll create my checklist here. Find the zeros. Looks like that flipped. Find the zeros, and then afterwards we're going to graph it. All right, so my 2 steps. So I start off with y is equal to x minus 1 times x plus 2. All right, so remember, if I was looking to find the zeros, what I could just do is I could just say x minus 1 times x plus 2 is equal to 0. And really, you're just saying y. In this case, we've just said we replace the 0 where the y was. That's all we've done. And I've written it on the left instead of on the right. You could have wrote it either way, doesn't matter. Remember, when we do this, we set each term, right, equal to 0. X plus 2 is equal to 0, the quantity of x minus 1. So I've go ahead and solve this, and I get x equals 1. I go ahead and solve this one, and I get x equals -2. All right, now that I've solved this, if I want to graph it, right, so if I'm drawing my y-axis here and my x-axis here, I'll say y and I'll say x. All right, so I have x equals 1. That's where x equal 1 is. Notice this is my x-axis, so x equals 1 is at 1, 0. X equals -2 is over here at -2, 0. That's why it's called finding your zeros, because you find your 0, 1, 0, -2, 0. All right? Now, this is going to be a parabola because we know that if I were to go through and multiply, let's say I multiply, I'll use the box method, right? If I were to multiply and find x minus 1, x plus 2, right? If I say x squared, here's 2x, here's -x, here's -2, I'd get x squared plus x minus 2. All right? And from here, I found where my what my equation would actually be. So if I were to graph this parabola, know that x squared plus x minus 2, know that's going to give me, since it's a quadratic, right, it's going to give me a shape that looks something like this, right? And knowing these are my zeros, this doesn't have to be a perfect graph. I'm just looking for a rough graph of what this would look like, right? Obviously, it's not perfect. But those are my zeros, where the quadratic, where the parabola actually crosses the x-axis, right? So your zeros are actually where your parabola, your U-shape, crosses the x-axis here and here, okay? And like I said, it doesn't have to be perfect, but you know it's going to be a parabola. And then I could just say like x squared plus x minus 2. That's what the graph would be. And you could test it out and put it in your graphing calculator and see if that's what you get. You know, we can graph it by hand. We can graph it by our calculator. If you test it in your calculator, it will look something like this. All right? That's number 5. Number 6. All right? So now we're getting the hang of this. That's number 6. Number 6 is y is equal to x minus 2 times x plus 9. The first step was that we found our zeros, and the second step was that we graphed it. So if we find the zeros, we can just say x minus 2 times x plus 9, set it equal to 0. And I can just say x minus 2 is equal to 0 and x plus 9 is equal to 0. Add 2 on each side here, and I get x equals 2. Subtract 9 on each side here, and I get x equals -9. Now that I've done that, I know where my zeros are. I can check that off. If I graph it, right, I'll make it look nice. This is my y-axis, and then there's my x-axis. Okay, y, x. And my zeros are at 2 and -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I'll go ahead and plot these. This is 2, 0, and this is -9, 0. Remember, these are along your x-axis. We call them zeros because they're where they cross the x-axis and give me a 0 for the y value. All right, so if I were to graph this, like I said, rough graph. Whoa, that was awful. It's going to come down something around there, come back up. I don't like it. Let's try it again. Not perfect, but good enough. I'll take it. Okay. I wonder if I actually like hold it there for a second. I wonder if it will like correct it. Yeah, look at that. That looks a lot better. I'll do something that looks like that. All right, not perfect, but all right. And if I really wanted to find out, you don't have to do this, but if I wanted to find out what it actually was as a quadratic, I could do something like this. I don't have to. It's not asking you to do it in the problem, but sometimes it's nice just to see what it is. Okay, this gives me x squared plus 7x minus 18. Okay, and that would be that graph. Like I said, you don't have to do that. We already found our zeros. We already graphed it. Number 7. All right. Number 7 says y is equal to x squared minus 2x minus 3. Okay, same things. We're going to find our zeros, and then we're going to graph it. All right, so first step, what I want to do is I want to be able to put this in factored form. Okay, the others were already in factored form, so I'm just going to take the extra step here, and I'm going to draw my box. I know it's a minus minus, so my answer has to be a minus plus. So one of these is minus, one of these is plus. Factors of 3 are negative, we'll just say 3 and 1. Let's try this, see if it works. X squared, negative 3x, got x, negative 3. Add up everything inside the box. And that gives me x squared minus 2x minus 3. Is that the same as what we started with up there? Yes. All right, so I'll say x minus 3, x plus 1. Right, so if I would have just started off and given you x minus 3 times x plus 1, right, you could have just started there, but I created an extra step for you guys on this one. All right, so x minus 3 times x plus 1 is what I had. I'm asked to find the zeros, right? So I can say x minus 3 is equal to 0, x plus 1 is equal to 0, add 3 to each side, and I get x equals 3. Subtract 1 from each side, I get x equals negative 1. Okay, so those are my zeros. X equals 3, x equals negative 1. If I were to go ahead and graph this, right? Look at that, that cleans it up nicer for me. Okay, this is my y-axis, this is my x-axis. Okay, x, 1, 2, 3. That's 3, 0. And then negative 1. That's negative 1, 0. And if I were to draw my parabola, it makes it look a lot nicer when I do it like that. All right, and there's my parabola, and the original equation I started with was y equals x squared minus 2x plus 3. So I found my zeros. That's what I did in this step right here, and then I graphed it, which you can see down there. Okay, and that's number 7. So now we're going to move into the second half of this lesson and move through number 8, and I'll go ahead and write it out first. Number 8, it starts with x plus 5 squared. And what it asks me to do is, it says expand using the distributive property. So I want to expand this. So how do I expand where I'm at? So really, whenever you're squaring something, that's just multiplying itself by itself. So if I had like, I don't know, if I had like 3 squared and said expand it, I'd say, oh, that's the same as saying 3 times 3, right? If I had like 4 to the 4th power, I'll change it. I'll say 2 to the 4th power. That's the same as saying 2 times 2 times 2 times 2 if I expand it, right? So by expanding it, I'm taking something here and making it bigger. I'm taking something here, making it bigger. I'm expanding it. So x plus 5 squared would be the same thing as saying x plus 5 times x plus 5. So it says expand using distributive property. That's all we had to do for number 8. Expand it, right? And these concepts and these principles we talk about in the beginning of this lesson, we're going to be expanding on next week in the next portion, in the next homework as well. And we're going to talk about Pascal's triangle a little bit here in a few minutes. But it's important that everything we've done up to now, that we start to just formulate it all together. And next week, we're going to be putting all these puzzle pieces together on why we're learning all this. So this is more of a review, just to remind you, hey, look, by the way, if you take, on number 9, if you take x minus 3 to the 3rd power, that's the same thing as saying, as writing this out, x minus 3, x minus 3, x minus 3, right? So I've expanded that out. And then also, we'll say number 10, if I have x plus 2 to the 4th, right? I could just say x plus 2 times x plus 2 times x plus 2 times x plus 2. Okay? So that's important to know. And I could just stop there and say, all right, we're just going to leave you, let you expand it out. What I would like to do next is go back to each of these problems. So if I look at number 8, and I have x plus 5 times x plus 5. So I'm just going to draw an arrow down here showing where we're at. X plus 5 times x plus 5. All right. If I were to actually use the box method, write this out. X times x is x squared. X times 5 is 5x. 5 times x is 5x. And 5 times 5 is 25. If I add up everything that's inside this box, I get x squared plus 10x plus 25. Okay, so I could write this as x squared plus 10x plus 25 and saying that I've expanded this out. Now, I have expanded it in this step right here, but eventually what I want to get to is this answer for number 8. Right, so if you just put for number 8, x plus 5 times x plus 5, I get that. But what we're going to be doing here, what we're going to be moving into in the next lesson, is we're going to start writing this out, okay? So for number 8, I'll go ahead and do it. I'll write each one out. So for number 9, and I would like for you guys to, since the directions do ask you to use distributive property, that you do this as well, okay? So if I have x minus 3 times x minus 3 times x minus 3. I'll start with the first two, right? I'll say x minus 3, x minus 3, x squared minus 3x minus 3x. That gives me a 9. X squared minus 3x minus 3x plus 9 gives me x squared. X squared minus 6x plus 9. And now that I have that, check this out. I still have to multiply it by x minus 3 again. So I'm going to have a bit of an expanded box, right? Because I have x squared negative 6x plus 9 times x minus 3 again. So x times x squared is x to the 3rd. X times negative 6x is negative 6x squared and I get 9x. I get negative 3x squared. I get positive 18x, and then I get negative 27. And if I add all this up, right, if I say x to the third minus 6x squared minus 3x squared plus 9x plus 18x minus 27, okay, I have x to the third. I have two like terms here, so I can say negative 9x squared. I have two like terms here because they both have an x, right? So that would be plus 27x, and then at the very end here, 1, 2, 3, 4, right? Plus 27. All right. So that's just important to go through and multiply out. I do think that once we go through this and talk about this more in the next lesson, you'll understand why we're doing this, but our answer in the very end for number 9 should look like that. Okay, and for number 10, I'll go ahead and do number 10 on the next page. Right, we had expanded it, so just to recall, we had x plus 2 to the 4th power. And I could write that out, x plus 2 times x plus 2 times x plus 2 times x plus 2. All right, so if I were to use the first two and just say, what is x plus 2 times x plus 2? Well, that gives me x squared, 2x, 2x, and 4. If I add all that up, that gives me x squared plus 4x plus 4. All right, then let's say I have to multiply. So we multiplied this times this. Now we have to multiply it by another x squared. So let's just say x squared. All right, and I'll draw my box now. And I'll say x to the third plus 4x squared plus 4x. And then 2 times x squared gives me 2x squared. I get 8x, and I get 8. If I add everything up, I get x to the third plus 2x squared plus 4x squared plus 8x plus 4x plus 8. Okay, so I could just say x to the third and then add these two terms. They're like terms, so I can combine them. These two are like terms, so I can combine them. And then I have plus 8. All right. And if I were to then multiply that, we multiplied this, this, and this. Now we have to multiply by the last one, x plus 2. This is where they start getting a little bit bigger here, right? You just got to go through and multiply these. X times x to the third is x to the fourth. And we get 6x to the third, 12x squared, 8x, 2x to the third, 12x squared, 24x, and then 16. So if I add all of this up, x to the fourth plus 2x to the third plus 6x to the third plus 12x squared plus 12x squared plus 24x plus 8x plus 16. All right, so, right, x to the fourth, these two are like terms, plus 8x to the third plus 24x squared, 3, 4, 1, 2, 3, 4, plus 32x plus 16. All right, and that would be my final answer. A lot of multiplication, right? But that's what we're going to eventually be doing moving on to next week. So we've introduced the binomial theorem, and we will introduce Pascal's triangle here right now, but this is this is important for next week, so I figured I'd at least introduce it, and you'll see it, and then we'll start to make more sense of it next week and using Pascal's triangle for an actual purpose rather than just learning it. And I've mentioned Pascal's triangle now for a couple minutes, and now we're going to actually do it. Number 11, it says, blank is a triangular array, right, of numbers in which the first and last number of each row is 1. Each of the other numbers in the row is the sum of the two numbers above it. So number 11, the answer is supposed to be a P, right? Pascal's triangle. Like I mentioned, Pascal was this famous French mathematician, and mathematicians are always researching and trying to find new patterns in mathematics. And Pascal discovered and started to write out that when dealing with the binomials, there's actually a way of writing these out when squaring or finding or cubing, or when you have a binomial and you're able to multiply these together, we're able to find patterns. So number 12, check this out. It says, complete rows 0 through 8 of Pascal's triangle. Well, I'm going to go ahead and show you this. So let's say, I'll say row, I'll start off with row 0. Okay, row 0, all you do is write a 1. And then you branch out, and you always draw 1s on the outside. Okay, so row 1 is you just branching out. Then you branch out again, and you write 1s, and we'll circle each, right? But you also now have these two together, and you just add them up. 1 plus 1 gives you 2. Okay, so that is row 2 of Pascal's triangle. Row 3, like I said, you always branch out from the 1s as the outsides, and then you add up what's in the middle, right? So 1 plus 2 gives me 3. 2 plus 1 gives me 3. And that's row 3 of Pascal's triangle. And it goes on forever, like an infinite number, right? So I'll go ahead and move my branch down here. You're going to add these numbers up. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is, whoops, not 3. 3 plus 1 is not 3. 3 plus 1 is 4. And that's row 4. All right, so I would continue this pattern, continue to go down, add 1 to the outside, and then figure out what these two add up to. So 1 plus 4 is 5, 4 plus 6 is 10, 4 plus 6 is 10, and 4 plus 1 is 5. Okay, once again, if I have 1s, 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 5 plus 10 is 15, and 5 plus 1 is 6. Okay, so this was row 5, this is row 6. We got 2 more rows to fill out, right? We want to get 7, we want to get row 8. So I expand it, I write the 1, add these two together all the way down. It's getting bigger and bigger. It will go on forever if you let it. 1 plus 6 is 7. 6 plus 15 is 21. 15 plus 20 is 35. Okay, 20 plus 15 is, once again, 35. 21 and 7. Now, if you notice a pattern, check this out. We have always like 1, 7. The 7s match on the end. The 21s match on the end. The 35 matches on the end. If you look at row 6, 20, and the 15s match, the 6 matches, and the 1 matches. So that's going to be true for the whole triangle. And we'll stop at row 8, but you can continue to go on. 1 plus 7 is 8. I get 28. I get 56. Yeah, that looks right. I get 70. And then 56. 28. 8. Okay. So those are the first 8, I guess, including rows 0 through 8 of Pascal's triangle. That goes on forever and ever and ever. And you might be wondering, why am I learning Pascal's triangle? Next week, when we talk more about the binomial theorem, we'll learn why this is so useful. Okay, and it has to deal with binomials. That when we multiply something like, I don't know, x plus 2 to the third power, how we can figure that out without actually like doing all those steps that we did. Check this out. Remember, like in the last page we did, right? All those steps, this entire page, just for solving x plus 2 to the fourth power, right? We did all of this just to finally get our answer in the end here. Whoops. Just to get our answer in the very end, which then becomes just, I guess, wasting of time when you can actually learn a trick. In Pascal's triangle, really, the purpose of it is it's a trick. It's a shortcut in a way. So, all right, trick / shortcut of how to solve problems like that. And we'll talk more about that. I'll explain more about it next week. But we want to be able to learn Pascal's triangle. And if I say, all right, write out Pascal's triangle through row 5, that you're able to do so. All right, you don't have to memorize it by any means. The way you would start it is by writing a 1 and then splitting that up. And then breaking off, always having the outside branches and adding up whatever's in the middle. Right, so if we were to do something like this and adding all that up, we would just continue that pattern. All right, so those are rows 0 through 8 of Pascal's triangle, and that is the completion of homework 16, polynomials and Pascal. If you have any questions, please let me know.